The perimeter of a square is 36. The area of the square is. If you have a square and the perimeter is 36, the square has 4 equal sides, right? So I'll call them all x. So that means the perimeter is equal to 4x. They're saying that perimeter is 36, and therefore 4x is equal to 36. So x would be 36 divided by 4, which is 9. So one side of the square is 9 units. Now the area of the square is x squared. So since x is 9, it would be 9 squared, and that is 81. So number 11, the answer is B. In the diagram, O is the center of a circle with radii 5, like this. This is 5, and this is 5. And the perimeter of the shaded region, including the 2 radii, is closest to. So they want you to find this perimeter right here, like that. And that basically means we have to figure out 3/4 of the circumference and then add this 5 and that 5. So that would be 10. So the perimeter will be 3/4 the circumference plus 10. Well, the circumference of any circle is given as pi times 2 times the radius. So the radius is 5. So this becomes 3 pi times 2 times 5 all over 4 plus 10. So this is, let's see here, 10 times 3, 30. 30 divided by 4, 7.5 pi plus 10. And they want, okay, they want it closest to. All right, so let's convert this, and this is about 33.5. So it's closest to 34. So number 14, the answer is A. In the diagram, the perimeter of the square PQRS is 120, and the perimeter of PZS is 2x. Which of the following expressions in terms of x is equal to the perimeter of pentagon PQRSZ? Well, the perimeter of the square is 120, so if each side is s, that means 4s is 120, s is 30. So this is 30, this is 30, and so on. Now, they're saying the perimeter of this triangle is 2x. So, written out, it would be PZ plus ZS plus 30 is equal to 2x. Okay? And then they want you to figure out the perimeter of this pentagon, 5-sided shape. Well, that perimeter would be 30 plus 30 plus 30 plus PZ plus ZS, correct? Well, PZ plus ZS is here. We can isolate for that. PZ plus ZS is 2x minus 30. So let's substitute that there. So this looks like 90 plus this is 2x minus 30. So that's going to be 60 plus 2x. And that's it. So number 17, the answer is C. In the diagram, PQR is right angled at P and PR is 12. If S is on PQ, so that SQ is 11 and SR is 13, the perimeter of QRS is. All right, well, we're going to have to figure out a few distances. First one is PS. We can figure that out easily with Pythagoras. 12 squared plus PS squared is 13 squared. And that means PS squared will be 5. And I'll let you do the math. So put 5 right here. And then we can figure out RQ using Pythagoras again. 12 squared this time plus that length, which is 5 plus 11, which is 16 squared, is equal to RQ squared. So that's going to be 144 plus 256, and that's 400. So that means RQ, if you take the square root, will be 20. So that's 20 right here. So finally, the perimeter of QRS is going to be 20 plus 13 plus 11, and that is 44. So number 11, the answer is B. 4 congruent rectangles and a square are assembled without overlapping to form a large square, as shown. Each of the rectangles has a perimeter of 40 centimeters. The total area of the large square is. Let's start labeling this. Let's call this segment X and this long segment Y. And therefore, this will be X, obviously, since that's a rectangle, and that's Y. And so is that. So each of these rectangles has a perimeter of 2y plus 2x. And they tell you the perimeter is 40. So that means 2y plus 2x is 40. And therefore, y plus x is equal to 20. Now they want you to figure out the area of the large square. Well, the area of the large square is just going to be x plus y times x plus y, right? Because from here to here is x, and therefore this whole side is x plus y. So the area of that big square is x plus y all squared, and x plus y is 20, so it's just 20 squared. So that is 400. So number 17, the answer is C. There is a square whose perimeter is the same as the perimeter of the triangle shown. The area of that square is. Well, first we need to figure out the perimeter of this triangle. Using Pythagoras, you can easily figure out this hypotenuse. 8 squared is equal to 6 squared plus 8 squared. So that gives you h is equal to 10. So the perimeter, therefore, is 10 plus 8 plus 6, which is 24. So if you have a square and its perimeter is 24, then that means each side is equal to 6. And they want you to figure out the area of the square. Well, the area is 6 times 6, which is 36. So number 16, the answer is D. In the diagram, 6 identical circles just touch the edges of rectangle PQRS, and each circle just touches the adjacent circles. The centers T, V, W, Y of 4 of these circles form a smaller rectangular T, V, Y, W, Y as shown. The centers U and X lie on this rectangle. If the perimeter of T, V, W, Y is 60, what is the area of PQRS? All right, well, what I'll do is I'll call the radii R, like that. Each of these is R. So the first thing, of course, is that the perimeter of TVWY is 60. TVWY, if you count up all the R's, I'll just keep labeling them like that. How many R's do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12R is the perimeter of TVWY, that rectangle. Well, they told me the perimeter is 60. So 12R is 60, and therefore R is equal to 5. Now they want you to find the area of PQRS. Well, PQRS, those dimensions are going to be 1, 2, 3, 4, 6R on this side, and 1, 2, 3, 4R on that side. So the area of PQRS will be 6R times 4R. That's 24R squared. R is 5, so 24 times 5 squared, 24 times 25, and that is 600. So number 17, the answer is A. A square has a perimeter of 28. The area of the square is. So here we have a square, and they are saying that the perimeter is 28. So P is 28. Now the side of the square we'll call X, and as you are well aware, a square has all 4 sides that are same. So that means that 4x is equal to 28, and therefore x is equal to 7. Now they want the area of the square, and the area of a square is given as x squared, if x is the side length. So now we just have to figure out what is x squared. Well, x is 7, So it becomes 7 squared, which is 49. So number 12, the answer is D. A piece of string fits exactly once around the perimeter of a square whose area is 144. Rounded to the nearest whole number, the area of the largest circle that can be formed with the piece of string is. So we've got some square, and they say that the area is 144. So since the area of a square is x squared, where x is the side, if that's 144, then that means x is equal to 12. So this is 12, this is 12, all the way around. Now they say that the string fits exactly once around. So the string is equivalent to the perimeter of the square, which is 12 times 4, which is 48. Then they say you have a circle that's formed from this string. So that means that the circle has a circumference of 48. So the circumference of this circle is 48, the same length as the string. And the circumference of a circle is given as pi times diameter, or pi times 2 times the radius. So this allows me to figure out the radius. So the radius is going to be 48 over 2 pi, or 24 over pi. And now they want you to figure out the area. So area of a circle is pi r squared, which is pi r is 24 over pi, all squared. So that's going to be pi times 24 squared over pi squared, and then that's just 24 squared over pi. And if you get out a calculator and do the math in terms of like an actual numerical value, you get approximately 183, because they want you to just round it to the nearest whole number. So number 20, the answer is E. Zara's bicycle tire has a circumference of 1.5 meters. If Zara travels 900 meters on her bike, how many full rotations will her tire make? Circumference is equal to 1.5 meters. So we travel 900 meters, and each time you have to cover 1.5 meters when you do a rotation. So 900 divided by 1.5 is the number of rotations, and when you do that math, you get 600. So number 12, the answer is C.